of Git. This is what I will be using for this session. You can either use the command window or even the terminal. The commands are all the same. So let's use this, and I would recommend this anyway. Let me increase the font size, and this is how your Git bash would tend to look like. First, we need to configure this. Any changes that you make in your files or any commits that you make, there should be and it should be able to show who made the changes. So for this, you should log into Git per se. So how you do this is with git config and then dash dash global and user.name with your name, and then same thing for email. So let's do it. Git config and then dash dash global and then user dot name, and then my name is Kashyap, so I'll just keep that. You can keep whatever, and then git config dash dash global again, and then user dot email, and then you can keep anything just to show that this is not any sort of authentication. I think this is just information that Git is taking to show who made each change in your file. So it need not be a valid email ID. So I can just enter a random thing like even a mistaken ID like .con or something instead of .com, and it would still accept it because this is just something that it is giving to like or show who made the change. It is not taking any sort of authentication. Although I would recommend you to put your email ID because that would be useful for linking this to your GitHub repository instead. So now that we have configured Git, let's start working on the files actually. Before that, we need to know a few terminologies. A repository is a Git virtual storage container where your files and your code are stored. So this is basically in Git terms a folder or a directory where you're working on your files. That's all. This we just call it as a repository. So with this, let's first make a repository on GitHub. For this, let's go to GitHub, and then here in the GitHub page, you can see in the side panel, your information is here and then your repositories, and then you can press this button to create a new repositories. This will show the list of your repositories. You should make a new one. So this will show the owner and then the repository name. We can name whatever. So let's keep it as repo trial, and then public or private. I will keep this as public for now. You can change it. And then all of this is optional. So we can just create the repository then. And then we have created a repository. We have just made the folder per se. So there are a bunch of information. We will get to all of this. So we have already made a repository now. Now, how do we work on this in Git? See, GitHub is just to store the repository online. You will not be working on it much. You will be using the files from that repository and working on it locally on your PC. So you should be able to clone the repository that is on GitHub so that you can work on it in Git in your PC. So for this, we should be able to clone the repository. Git clone is the command used for this operation. So let's see how we can do this. So we can clone a GitHub repository using its URL. Now in this page, we have seen this sort of information is there. This thing is the URL of this repository. We will need that. So let's copy that and then go back here. And it says we have to perform a git clone with the URL. So let's go to git bash, and then first let's go into the directory in which we want to make this repository at. So I'll go to desktop, and then I'll just make a new directory called git, and then cd git. CD is just a Linux command that is used to go to a directory that is mentioned. So now I have gone to the directory of git in desktop. So now let's say I want to make my repository over here. I want to clone it over here. For this, I will do git clone with the URL. So I will paste the URL over here. Sorry, not this. This. And then if I press enter, it says cloning into repo trial, and it gives a warning that it's an empty repository. If it's not an empty one, it does not give this warning. Don't worry. So now we have cloned the repository. Now, if you do ls, this command in Linux and the terminal is used to show the directories and the files that are present in the directory that you're currently at. If we do that, it shows that we have a directory called repo trial. Now let's quickly go into that and look at how it is. So if we do this, there comes this thing called a main. What this is, we will get to it. This is called the branch of the repo that we are currently at. We will get to that later on. And let's see some other external features. As this is an empty repository, doing ls will not show anything, but there is another command in Linux, ls minus a with the flag a to show even hidden files. If we do this, it shows .git. This is a hidden folder that stores all of the commits and all of the information related to those. And we won't be able to directly access it, but we'll be able to use commands and access it indirectly. So this is the indication that our folder is in fact a Git repository instead. So we have a repository now cloned from our GitHub. So let's move on. Now let's say we don't have a GitHub repository that we are cloning from, and we want to make a new folder or a directory as a Git repository. For this, we just use git init. So how we do this? Let's go back. We do cd dot dot to go back in the previous directory, and then we can make a new directory called new directory or something. So let's go into this. Sorry, cd. With this, we are in the directory. Now, if we want to convert this directory into a Git repository, we just do git init. And it says initialized empty Git repository in this. And it says again master. This is the name of the branch. Again, what it is, we will get to it later on. And again, if we do ls minus a, it shows .git. So we know that we have made this as a repository. So now that we have repositories, we should start working on our files. Before that, we have another command just to see the status of the repository. That is to see if there are any files to be committed or added to the staging area or made any commit on. So this is just something that we will be using to check how the status of the repo is going on. So now for the actual making of the files and making the commits, what a commit is in Git terms, making a checkpoint, that is releasing your file versions. Now, suppose you are done with some part of your code and you want to make a version of that at that point. That process in Git is called committing the change. So let's say, let's make a new file called um, 1.txt. So with this, if we do git status, it says there is one untracked file 1.txt because we have not added this to any commit or whatsoever. So let's try to commit the changes of what we have made. Let's say, let's try to add some info to this. With this, let's say this is my first file and then save this. So we have added some info into this. Now if we do git status, it says again the same thing, untracked. So let's try to commit the changes to this. For this, we have to add the file into a thing called the staging area. Now, suppose you're working on a lot of files and you don't want to like release the versions to all of them at once. Only some of them you want to make a version of. In this case, you need to be able to add only some of them, for which we need to add them to a separate area called a staging area and then commit the change from the files of only the staging area. So to add files to the staging area, we do git add and then the file name. So this is not just one file that you have over here. You can add multiple files with a space link over here. Now let's say I have another touch info. By the way, touch is just a Linux function that is used to add a file. So I just added another info.txt. Now suppose I want to commit the changes to both of these. So I need to add them to the staging area first, for which I will do git add, and then I will add 1.txt first. And then if I want to add info again, I can do info.txt again to this with a space in the same command. You don't have to do it twice. So with this, you can do this. It gives a warning and which says that in this, there's the LF will be replaced by CRLF. Don't worry about this. This is just how a file ends, and LF is based on Linux and then CRLF is based on Windows. And because I used VI software, which is a Linux software, it gives this error. It is not something you need to worry about. So we have added these two files to the staging area now. So if we do git status now, it says changes to be committed instead of untracked files, because these two files are now in the staging area, and it says new file because this is This is not there in any other previous commits. So now we have added files to the staging area. Now we can commit our changes. For this, it says the commit message, the commit command is git commit with flag -m of a commit message. So see, whenever you were making a commit, you need to give a message as to what you have done in that commit, just so you can see it more clearly and understand what is happening there. Otherwise, you won't know what the commit is for. This is the only thing that says what the commit is for. So if we do, sorry, git commit and then -m, this says, let's say first commit, and it says all of this. So our commit is made. Wait, before this, let's do git status. And it says now nothing to commit, working tree clean, because all of the files in our repository have been committed already and there are no untracked files in this. So now that we have done that, we have another command called git log, and this shows a list of all the commits that were made in that repository. So if we do git log over here, and then it says commit with a bunch of characters, this we will get to what this is. So it says author and then Kashyap at gmail.com. That is what we had given initially, and this is why we had configured initially. And then it saves date and time, and then the commit message. And this thing says that the head, that is we are at this commit, because that is our first commit. This is where we are at. And this is the branch that this commit is made in. Again, branches we will get to later on in this session. So now that we have that done, okay, before this, let's make another commit so that we can see how version control happens. Now, let's go to info.txt. Initially, there was nothing, right? We had just added the file. So this is an info file. Let's save that. And if we do git status, we see that we have modified the file and we have not committed it. So let's quickly commit this. And also to add it to the staging area, you don't always have to give the name of the file. If you want to add all of your files to the staging area, you can just do git add full stop. This adds all the files that are there in the repository into the staging area. So again, this warning has come. Don't worry about it. So if you do git status again, it says we have modified this file and the changes are to be committed, and it is not in red, it's in green. So it is in the staging area. Now, if we can do git commit again with -m added info, whatever message. So if we do git log now, it shows two commits. The one that we have made just now with added info and the one before, that is first commit. So there are two of them. Now let's say I wanted to check the files that were there in this, that is the version 1, what the info.txt said. For this, we should be able to go back to a previous version. That is exactly the use of git in the first place. So for this, we are using the command git checkout, that is used to go to a previous checkpoint, or you can call a previous commit. So it is used alongside with a commit hash. Now, when you're working with all of these versions, you should know which version, that is which commit you need to be going to exactly. There should be something to uniquely identify each commit. If you consider the commit message, then there is no restriction that two commits will have different messages every time. So we cannot really use commit messages for this. So for this, we use commit hashes. These characters that you see at the end in git log, these are called the commit hashes, and these uniquely identify that commit. So this is what we will use to go to each commit. So git checkout and commit hash goes to whatever commit that we need. So for example, we need to go to this commit. We are currently at this because this is the latest one and head says we are at this. So let's copy this and then git checkout, and then we can paste it. It will give a bunch of information. We just need to look at the last line. Head is now at this. That is first commit. So this is our commit message, and this is the starting few letters of our commit hash. You can see over here, it is this. So this also changed from master to this starting few letters of this commit. So remember how in the previous commit, we had not added any information to info.txt. So if we just go to info.txt, There is nothing because at this commit, there nothing was committed. So now if we want to go back to the latest commit, we have to use git checkout master. That is the branch name that you are in. And this is what we have seen so far. Git checkout master takes you to the latest commit on that branch. So git checkout master, if we do, again, this changes to master. And then if we do, uh, sorry, vi info.txt, this shows this information. This is an info file. This is what our latest commit had. So we can just move on to the next part. Okay, before I move on, this is the attendance QR. Please scan this to fill in your attendance. I will wait for about 2 minutes or so. Because I am the only presenter over here, this is the only time where you will get the attendance. So please make sure to fill this as soon as possible. This is the only time that you can fill the attendance. Okay, I'm hoping every one of you fill the attendance. I will be moving on. This is a very important branch. I mean, very important topic, that is branches. So for now, we have seen that we had worked on a branch called master, and I mentioned that I'll be talking about that. So branches in Git are where you're storing the commits. So let's take this as an example of tree branch, and each leaf of that branch is the commit over here. So each commit is stored in a separate in the branch that you're working on. Now, suppose in Git you're trying to work on a new thing, and you do it's kind of experimental, so you don't want it to meddle with the important files on the master branch. You want it to be experimental and worked elsewhere. Instead of working on a new repository, you can make a new branch instead and work on your commits in that. And if it happens to be working well and you want to merge it with the main branch, you can do so. Or if you don't want the changes and it did not go well, you can delete the branch. So this is where you can work on like different sort of changes and have all of them saved. So far we have worked only on the master branch, and now we'll be looking at how we can work on different branches. And git branch is the command that we use for these operations. Just doing git branch shows the list of branches. So if we just do git branch over here, it shows only the master because we don't have any other new branches and we have not made any other branches. So to make a new branch, we use the command git branch with the branch name. So let's quickly do that. Git branch, and let's call this new branch. So it does not do anything. It just makes a new branch. So we can do git branch again, and it shows the two branches now. And notice how master is highlighted with green and there's a star over here. This is the indication that you are currently in the master branch. And this is also an indicator, by the way. This is just another indicator when you are running the Git branch. So now that we have made the branch, we should be able to go and work on that branch. So let's switch the branch from the master to the new branch. For this, we use the checkout operation again, but instead of the commit hash, instead we are using the branch name now. So for this, we'll do git checkout and then new branch. With this, it says switched to branch, new branch. And now it shows up as new branch over here, indicating us that we are in the new branch. Let's just do git branch again, just to check. And again, it says new branch is highlighted. So we are in the new branch. So in this, we can work on any new commits and it won't be saved in the master. It will be saved in the new branch instead. And you can merge it with the master later on if you want. And then again, let's work on a few things and look at it. Wait, before that, there's another command called git checkout -b. So, like this is actually a convenience command. So for making a branch and then switching to the branch, we use two commands. You see git checkout new branch and then sorry, git branch new branch and git checkout new branch. These are the two commands that we use to make a branch and switch to it. Else you can just do git checkout with the flag -b and then just do branch 2. This makes a new branch and switches to it at the same time. This is just accumulation of both of those commands, and this is just convenience. So as you can see, we had no branch before called branch 2, but now we have made the new branch as well as switched to it. So I just wanted to talk about that. Now, let's say we are working on a few files here. Let's do vi 2.txt. And then this is my second file. Let's save this. So now if we do git status, it says untracked files again. Let's commit this git add dot and then git commit -m second file addition or whatever as the message. Now if we do git log, now this is very important. Now you see it shows all of them and it shows the branches as well. It says the head is at branch 2 and then this commit is made at branch 2, whereas these are made at master and the new branch is also at this commit. That is nothing else is committed on that. Now suppose I want to merge this second commit with the master branch. Now for that we use the operation git merge with the branch name. So talking about this, be careful while using this. You should use this operation when you are merging the branch from a different branch to the branch that you are in. So for example, for now we are trying to merge branch 2 with master. So for that, you need to execute this command when you are in the master branch. That is when you are in the branch that you want to merge it to, not merge it from. So this is not where we do this. We don't do git merge branch 2 here as we are already in the branch 2. So first we have to go to master branch for this git checkout master and then go to the master branch. And from here, we have to merge the branches. So we do git merge over here with branch 2 and it says updating a few things. And then now if we do git log, it says master over here and this is merged. So we have merged those two branches. Deleting branches now let's say you're done working with the branch 2, that is whatever you wanted to do on the branch 2, you're happy with that and you wanted to merge it to master and you have done so. Now that you have done working with branch 2, just to keep your repository clean, you want to delete branch 2. Now for this we use the command git branch with the flag -d and then the branch name branch 2. It says deleted branch 2, and if we do git branch now, it does not show branch 2 because we have deleted it. Now let's go to new branch and try one thing out. Git checkout new branch. And then let's make a few commits over here. Let's do vi3.txt now and do this is my third file, and then save this, and then git add dot forward into the staging area, and then git commit -m third file addition. So we have committed the changes, and git log says that this is at the new branch. And then now let's say we are trying to delete new branch, and notice we have not merged new branch with the master branch. So the commit that we have currently made is limited only to the new branch. It is not anywhere else. So if we directly try to delete this, git branch -d new branch, it gives an error. Cannot delete new branch because we have not. Okay, wait, let's try to go over to the master branch instead and try this. It says error. The new branch is not fully merged. That is, whatever commits you have made over there, it is not merged to a different branch. So you may be losing your progress. So for that, it throws an error. And suppose now you don't want those commits. It is commits that you don't want. You tried something and it did not work out and you want to just delete them. So for this, you will be forcibly deleting these branches. And this itself gives the command that is git branch with the flag of capital D instead of small d now with the branch name. So we can do git branch minus capital D this time and new branch. And now it says deleted branch, new branch. Now if we do git branch now, we can see that the only branch now is master because we have deleted the other two branches. So we have seen merging branches and deleting branches. Now we have learned everything that we know, everything that we need to know for making changes to your local repository and working on it. Now, suppose you are done working locally by yourself and you want to be able to transfer your commits to the GitHub repository where others can access your commits. Now, remember this, we are not transferring files, we are transferring commits from the Git repository to the GitHub repository. That is the local repository to the remote repository on GitHub. So for this, we are pushing the commits. That is the terminology that we use in Git. Git push is what we use for this. So we are trying to push the commits from this master branch onto that. For this, let's look at it. Let's look at a few information before that. Now the local repository should be somehow connected to the remote repository in GitHub. And this connection is made using a remote. That is what we call it. And this remote is actually the URL of the repository itself. That is, if we go into GitHub, this URL that we saw before while cloning the repository itself, the same thing is used as a remote. So let's copy that again. So this is what we are using as the remote for pushing our commits. So how we add a remote to a repository is by using git remote add. And then notice this git remote add origin and then remote URL. So this origin, what this origin is the name that we are keeping for this remote. We are going to be using this remote and there can be several remotes on a repository. So we need to name each remote. So for this, we will be adding a name to this. Origin is something that we call it by default in the community. If you want, you can name it anything else. Again, it's the same similarity as how master is the main branch. You can name it anything else, but by default, it is the master. And again, if you want to add a new remote when there is already an existing remote, we call it an upstream. Again, it's a default name. You can name it whatever you want. So let's try to add, sorry, not this. Let's try to add this remote onto our repository. For this, we need git remote and then add, and then let's call this an origin itself. Before that, there is a command to check what remotes are present in your repository. That is git remote -v. That is the flag is v. It does not show anything because there is no remotes that we have added. So let's add our remote. For this, we need git remote add, and then let's call this the origin again for default, and then paste the URL. And then if we do this, it does nothing. But if we do git remote -v again, it shows that the fetch and push remotes are both made to the origin. The fetch is so that you can fetch the commits from the GitHub repository, and push is where you can push the commits from this repo into the GitHub repo. So by default, both of them are made to the origin. You can change this if you want by adding more remotes. So now that we have done that, now this, as you have seen, git remote add, and then for checking what remotes are existing on the repo, you can do git remote -v, as I said. So now that we have added a remote, we should be able to push our commits from the Git repo onto the GitHub repo. What the command we use is git push. And then the syntax is git push remote. And then what this remote is the name of the remote. So in our case, this is origin. And if you name it anything else, that will be the name of the remote. And then local branch colon remote branch. Local branch is the branch from in the Git repository, that is the local repository that you're committing, that are pushing the commits from. That is, in our Git repository, the branch that has the commits is the master branch. So in our case, the local branch is master. We are pushing the commits from master. And then remote branch is the name of the branch on the GitHub repository, that is the remote repository online, onto which we are pushing these commits. So by default, the branch name in GitHub is main, not master. So for this, if we don't change it, then it has to be master itself. So in our case, we perform git push and the name of our remote is origin, and then local branch is master, as I said, colon remote branch is main. So git push origin master colon main is our way to push our changes. So if we go into git bash again, so we do git push and then origin, name of the remote, and then master, the local branch, and then main, the remote branch. So doing this should push our commits from the master of our repo to the main of the GitHub repo. So before doing this, I will mention if you press this for the first time, I mean, if you enter this for the first time in your git bash, it will take you to a sign up page to your GitHub account, because you should not be able to like push your commits to some random person's GitHub repo. You should be authenticated with your GitHub account so that you should be able to add your commits onto there. So it will show you a sign in page and you can press on sign in with browser, and you have to just authenticate this connection because you're already signed in with GitHub on your browser. So it's just a simple process. I will skip that and I've already done it. So if I just enter this, it should push the changes. So it gives a bunch of info, enumerating objects, counting objects, delta compression, compressing objects, all of that. And then it says master to main. This is what we need. From master, we have pushed our changes to the main. So if we go into GitHub, as you can see before, we just made an empty repository over here. That is, there was nothing over here. If we refresh this page, then we can see a few files over here. That is the 1.txt that we had with the content. This is my first file. 2.txt, this is my second file, and info.txt, this is an info file. So these are all the commits that we had. Now, if we go back to the repository, this says that there are 3 commits. And if we look at this, our commit names are intact. First commit added info and second file addition. So whatever commit messages that we have given in our Git repo, the same things show up over here along with the same versions and the same files. And also notice that the time is also along the same as what we did in Git. Even though we have pushed the commits from Git onto GitHub like a minute ago, it says 23 minutes ago. That is when we actually made the commit on Git. So it remembers the timestamps from then. This is quite useful. And then if we check this, these commit hashes are identical to the commit hashes that we have in Git. So if we do git log over here, remember the first few characters, 3F62624 and then 77528 and then 07FE31. So if you see, those are the exact same. So all of the contents will be the exact same, including the commit hashes, the commit messages, the timestamps, and who made the commits, the name, again, all of that is intact. And again, the codes will also be there. If you press one of these, it shows you what changes were made. So if you see this line is made green, that means I have added this line. So if I have removed a line, it says red and then shows the content that I have removed. So this is what it is. If you see this, if it says if this commit is yours, make sure this is associated with your account and to claim this. So for this sake, I recommended you to give your actual GitHub email account. And this is just for like identification purposes. That's all. So if you go to some other commit instead, not the latest one, it also shows what we have done over here. Again, we have changed the info file in the second commit. So we had added info over here. So it is again a green line. So before we wrap this up, so let's try to make another commit where we remove a line and then add another line. So let's go to info.txt and then remove this line and say this is changed or whatever. And then now we can do git add dot and then git commit -m changed info. And we have committed the change. Again, we can push the changes onto GitHub to check on that. So we can again do git push and then origin, the remote name, and then master branch on the local repository to the main branch on the remote repository. This again does the same operations and shows up the same info. So if you refresh again, now in this case, it says 4 commits and 1 made now. So if you check this commit, there is a red line and 2 green lines. The red line shows that I have removed this information from my file. And then the green shows that I have made this. Notice that I had pressed an enter before entering this line. So the enter, that is the new line that I had done, is also noted down. And that is what is shown here. I just wanted to show what this red line means. So we have removed this file. Remove this line is what this means. So we have successfully transferred our commits from the Git repo onto the GitHub repository. And again, if we check info.txt, this has changed. So let's go back. And with this, let's just recap on the topics that were discussed today. We discussed about repositories. Repositories are storage containers in Git in which we work on our files and codes. And it is a Git term for a folder or a directory. Git clone is used to clone a directory from GitHub onto your Git in your local PC. And then Git init is used to convert a directory into a Git repository. And then Git add is used to add your files that you want to commit changes on to the staging area. And then git commit is used to actually make the commit alongside with the commit message, of course. And then I have not actually showed this, but if you try to make a git commit without giving the commit message, it shows an error asking you to give a message. So it is not possible to make a commit without giving a commit message. And then git checkout is used to go back to a previous commit and check the version of the files over there. Or it can be also used to switch to a different branch. And then branches is where we work on different commits at the same time. And then git branch is used to make a new branch or view branches, etc. And then git merge used to merge branches, merge two branches, and then remote, that is what is used to connect the local repository to the remote repository, and then git push, which is the command used to push your commits from the local repository to the remote repository on GitHub. With this, I have finished the introduction to GitHub session, and there'll be another session on Git, that is the advanced topics on Git, later on in CodeCraft itself. So be sure to attend that in order to be well versed in Git. And then after this, we will be sharing another Git repository containing a few questions so that you can practice these commands yourself on your Git and on your PC. And then I will be sharing these slides as well so that you can check for any syntaxes or whatever. And feel free to contact me if you have any sort of doubts you have on this. And then after that, please fill the feedback form, guys, on this session so that we can improve the further sessions in CodeCraft. Thank you very much for joining the session. You can leave after filling the feedback form.